Hello everyone, let's talk a little bit about static equilibrium. So we've talked about this already a little bit, but let's kind of dive into it a little bit deeper. So again, static equilibrium means the sum of the forces acting on an object. These are going to generally be extended bodies, not point particles, although it would also work for point particles, but the sum of the forces acting on the object will be zero. And then the sum of the moments acting on the object will be zero. And these are both vector quantities, you want to keep that in mind. But we're going to start off simplistically, we're going to look at two dimensions. And when we do this, when we look at the sum of the forces and the sum of the moments in two dimensions, we're going to end up having these connections as part of the extended bodies. And we want to talk a little bit about those different connections. So, a couple of different connections and rollers. Okay, a roller is like a wheel. You can think of a roller skate, right? That's a wheel that's free to go. So here I've got a wheel. And as I put forces down here with my hands, the wheel is free to roll left and right. So the wheel cannot exert a force on whatever's attached to it. It cannot exert a force left and right because it's free to move left and right. And so the force acting on the object because of the wheel must be normal to the surface. In addition, the wheel rotates, and so the connection is free to rotate. So the wheel is going to allow no moments to be exerted on whatever's attached to it. Okay, so the forces due to a roller or a wheel must only be normal to the surface. Now the surface doesn't need to be horizontal. It could be at an angle, it could even be vertical. But the forces can only be normal. So they're basically normal forces. But it will exert no moments either. Okay, so that's the wheel or the roller. And then we might have a cable. Well, let me grab that wheel back. So this is a rope, and forget the wheel for a second, but the rope is pulling on this hub. It can only pull in the direction of the cable, right? It can only pull in the direction of the cable. But we also have the possibility of something like a light beam. Okay, so if this is member number one, and then, well, let's say member one is in my left hand, so this down here, and member two is this one. This is pulling on member one. Member two is pulling on member one with a tension or pushing, right? I can also push on member one with a compression. So what I'm going to call a light beam, and there are other names, but it's basically not much mass to it, if any, but it's only going to exert forces along its length. All right, so a cable or a light beam, they can exert tensions. In the case of the beam, it can be a tension or a compression, but only in the direction of the cable or only in the direction of the light beam. Then we've got collars. Okay, so a collar might be, let's say there's a member here, the collar might be like my fist. And so this beam is free to slide. It's going to be frictionless collar. It's free to slide along here, but no rotation is possible, right? So it's not going to allow a moment. So it can exert a moment on this. We're going to look at the forces acting on the ruler here. It can exert a moment on the ruler, but it exerts no forces along the slot or the length, the direction of the collar, right? Except it will exert normal forces. So it could exert a force normal to the collar, okay, normal to the beam here, but not along the beam. It will not exert forces along the ruler. It can exert moments, so it will be able to keep it from rotating. So it can exert a moment on the ruler. Pins in slots would be very similar to the collars. Okay, then there's a pin support itself. Okay, so let's take a look at a pin support. All right. So in this case, the pin will not allow it will not allow movement up and down. It will not allow movement left and right, but it will allow rotation. So the pin exerts no moment, but it can exert a force in the X and the force in the Y. So that's what a pin support will do. And then a fixed support, I'm just going to add another screw in here. A fixed support will not allow forces in the X. It will not allow forces in the Y. Okay, Okay, but it will also not allow rotation. This one's a little loose, but you get the idea. Right? I could do the same thing just by holding my fist. Rotation is not allowed by the fixed support, and so it's exerting a moment. So the fixed support can exert moments, and it will exert forces X and Y. Pin supports will exert forces X and Y, but will not exert moments. Collars or pins inside of slots will not exert forces along the slot or along the collar, but they will exert forces normal to those, and they will, well, collars might not allow a moment. If it's on a swivel, it will not exert a moment, but a fixed collar won't allow any twisting, so it's exerting moments as well. A little bit of both in those. A cable or a light beam does not exert does not exert moments, but it will exert forces along the cable or along the direction of the light beam. And then rollers will only exert forces in the normal. They will not exert any moments. So these are the kinds of shapes that we're going to have in 2 dimensions. We have similar things in 3 dimensions. We'll talk about those in a later video. All right, thank you. If you have any questions, please leave them in the comments below. Thank you.